Hi, this is Mr. McWhorter, and this is the Algebra 1 Unit 3 test prep video. First thing you should do is click on the Unit 3 tab in Open Class and download and print out the practice test. Once you've done that, it's time to begin. First of all, we're going to look at functions. Chris earns $12 for each lawn that he mows. Define the two variables in this situation and state which quantity is a function of the other. Okay, so we need to come up with some variables. So there's the lawns that he mows, that's one, and then there's the money that he earns, that's the other one. So let's let the variable L represent the number of lawns that Chris mows. And let's let the variable A represent the amount of money that he earns. And you can pick different letters if you want, it doesn't matter, as long as you tell me what the letter represents. So in this situation, the amount of money that he makes depends on how many lawns he mows. So A is going to be a function of L. Now we're going to use those variables that we just defined to write a function using function notation. So we want to find out the amount of money that he makes, and that is a function of the number of lawns he mows. And the amount is $12 times the number of lawns that he mows. So there's our function. A of L is 12L. So now we're going to use that function and we're going to start evaluating it. During the last 4 weeks, he mows the following numbers of lawns: 17, 22, 9, and 19. And let's determine his weekly income for each of these weeks. So the amount he makes as a function of the number of lawns he mows is 12 times the number of lawns that he mows. If we want to evaluate the function for different numbers of lawns, all we have to do is plug in for L those different numbers of lawns. So in week 1 he did 17 lawns, so we're going to plug in 17. And A of 17 is 12 times 17, which is $204 he made that week. For week 2, he mowed 22 lawns, so we're going to do A of 22, and 12 times 22 is $264. In week 3, he mowed 9 lawns, so our input into the function is going to be 9, and the output, 12 times 9, is 108. For week 4, the input is 19 lawns, 12 times 19 is the output, 228 lawns. And what was Chris's average weekly income? Well, to find the average, we just add up the amounts of money that he made and we divide by how many of those there are. So there's 4 of them. Go add them all up. That's $804 divided by 4. So his average weekly income was $201. Jeff and Maria created some mapping diagrams to model real-world situations. Complete and interpret each diagram. Jeff plays darts. In a certain dart game, he earns bonus points for hitting consecutive bullseyes. The first bullseye is worth 100 points, and the bonus is then doubled for each consecutive bullseye. The input of the function S of B is B, so that's our input, and that's the number of consecutive bullseyes, and the output is S, the number of bonus points earned. Complete the mapping diagram. So 1 bullseye gets us a bonus of 100 points. 2 bullseyes, the bonus gets doubled to 200. So for 3 bullseyes, the bonus of 200 is getting doubled, which is going to be 400. For 4 bullseyes, the 400 gets doubled to 800. And for 5 bullseyes in a row, the 800 will be doubled to be 1600. So does Jeff's mapping diagram represent a function or a relation? Well, it's a function as long as each input only gets mapped to one output. And I don't see any input here that's going to two different outputs, so Jeff's mapping diagram represents a function because each input maps to exactly one output. Maria is playing a game with a 6-sided die. The number rolled is subtracted from 7 to determine the number of spaces moved. However, if a 3 is rolled, the player can choose, so if a 3 is rolled, this is important, the player can choose to move either 1 or 4 spaces. Describe the inputs and outputs of m of n, the function, and complete the mapping diagram. So the inputs are going to be the n's. So the input of the function m of n is n, the number rolled on the die. The output is going to be m. So the output is m, the number of spaces the player moves. So now let's complete the mapping diagram. Let's see. So the number rolled is subtracted from 7 to determine the number of spaces. So if you roll a 1, 7 minus 1 is 6. Okay. If you roll a 2, 7 minus 2 is 5. So if you roll a 3, 7 minus 3 is 4. Let's go down and look at 6. If you roll a 6, 7 minus 6 is 1. If you roll a 4, 7 minus 4 is 3. If you roll a 3, 7 minus 3 is 4. But you also get the option, you can either move 4 spaces or you can move 1 space. So here's another place you could go. And you should notice something right about now. And the thing that you might notice is that the input 3 seems to be going to 2 different outputs. I don't know if you noticed that or not. But that kind of breaks our rule of being a function. So Maria's mapping diagram represents a relation, not a function, because the input 3 maps to 2 different outputs, maps to 1 and 4. So this table shows some input and output values for a function named f of n. And we need to write a complete sentence that expresses the pattern of f of n. So when n is 0, our output is 2. When n is 1, our output is 5. So it seems to, it went up by 3 here. Then when our input is 2, we don't quite know what it is. But when it's 3, it's 11. So we made 2 jumps here and it went up by 6. Then when our input goes from 3 up to 4, we're jumping up by 3 again. From 4 to 5, our output jumps up by 3 again. And then on this last step, it jumps up by 3 again. So it looks like we're adding 3 each time. And you can see on the missing step here, when our input went up twice, we went up by 6. So it would make sense that for each step, it went up 3. So a complete sentence that expresses this pattern. Well, we start with an output of 2, and then each time our input goes up 1, our output goes up 3. So here's a couple of complete sentences. When the input is 0, the output is 2. Then, each time the input increases by 1, the output increases by 3. So now we need to figure out how to write this function pattern as an equation. Well, we start with a value of 2, and then we're adding 3 a certain number of times. And when n is 0, we're adding 3 0 times. When n is 1, we're adding 3 1 time. When n is 2, we're going to add 3 2 times. So whatever n is, we're going to start with 2, and then we're going to add 3 n times. So we would normally write it in what we call descending order, like this. 3 times n plus 2. And we can double check and make sure that this works for the different input values in our chart. We should be able to plug in a 5. F of 5 is 3 times 5 plus 2. That's 15 plus 2, and that is 17, and that works out. And you can check it for all of these and see that it works for all of them. So, looks like our function notation is f of n is 3n plus 2. So now we're going to use this function to evaluate for the missing values in our table. When n is 2, we can use the function like this. F of 2 equals 3 times 2 plus 2. So that's 3 times 2 is 6, plus 2 is 8. And when the n is missing, we know that f of n is 20. So we're going to say 20 equals 3n plus 2. Then we can subtract 2 from both sides. We get 18 equals 3n. Divide both sides by 3. And we're going to get n equals 18 divided by 3 is 6. Now we need to find the value of f of 13 minus f of 9. So I'm going to do a little color coding here. F of 13 will be in green and f of 9 will be in blue. So f of n is 3 times the input n plus 2. So in order to do f of 13 minus f of 9, we're going to do, here's the rule for f of 13, 3 times the input plus 2, minus f of 9, 3 times the input plus 2. So f of 13 is in the green, and f of 9 is in the blue. And now we just need to multiply and do the arithmetic to finish this. 3 times 13 is 39, 3 times 9 is 27. Now inside the parentheses, 27 plus 2 is 29, and out here 39 plus 2 is 41. So it's now 41 minus 29, which is 12. So f of 13 minus f of 9 equals 12. And that concludes part 1 of this video. Tune in next time for part 2.